run the hackathon code that we have submitted as part of our submission. So our project name is Custimer. It's a play on the word of customer and timer, like to time how long your customers are in various parts of your store. So we are three members in the team. We have Briana, Kallis, and myself, Akash. So we have the README file, which is pretty straightforward in terms of understanding what all is needed. So either if you download the zip from GitHub, or if you use the extracted or the uploaded file from HackerEarth, these are the files that would be present, except for just one single file, which is a bit large in size. So it should be there in the zip file uploaded to HackerEarth, or you can directly download it from the drive link that is mentioned over here as well. So I'll just walk through quickly over the steps that are needed to deploy this. The first thing that we need is Anaconda. So Anaconda is a Python toolkit to help with development across multiple systems, and we use that to create a virtual environment, which is a good way of abstracting away and not interfering with other projects as and when you do development. So the first thing we do is create a virtual environment. So in this case, I've called it as TSC, and then once it's built, we activate it, and then everything that you do inside of this virtual environment is isolated from rest of your system as such. So like I mentioned previously, this specific file, crowdhuman YOLO v5 medium m.pt, this file has to be present. If it is not, then you can just fetch it from the drive link as well. And once it is fetched, you can just place it at the root directory itself. There is no need to put it anywhere inside any of the subfolders as such. And then there's just one single step more for installation, that is pip3 install requirement. So all of the Python modules that are needed for working are here. So it's only 25 modules, and of which a few of them are basic or like inbuilt modules itself. So nothing too complex. And once that is also installed, depending on your system, you might need to switch things up. I'm running on Mac OS, so these are the only steps that are needed right now. And in order to run this on the local machine itself, on your computer itself, the only step that you need to do is use this command. So I've already activated my environment, so that's why you can see TSC over here. So if I go ahead and deactivate it, yeah. So just counter deactivate is enough to bring it back to the base environment. So from here, you can explicitly go to activate any environment, and in this case, it is the TSC environment that I've created previously, and that is created with this step itself. So once that is done, you can just activate it again. So now you can see TSC showing up here. I've already run pip install requirement, so I don't have to run it again. But you can run it on your own machines as well. And then the last step is to simply start the server. So we are using Fast API instead of Flask, and it's a good asynchronous web server for Python. I mean, all the benchmarks have shown it to be clearly better than Flask for most use cases. So we also like ended up using it as well. So I can show you what all the commands mean. So here the host is to bind to all of a network at network interface cards. So this is just a default. So here it could be localhost as well if you don't pass it explicitly. Passing 00 makes sure that devices outside of a network can access it to the actual IP of the device as well. So right now it's on the local machine, so it can still be reached at 00 IP as well. Then the port. So if it is defined in the environment, it will take one. If it is not, then it takes in 5000 as the default port. And just we have some logging enabled and a reload as well. So in case there is any changes to the code, it will just automatically reload the server as well. So that's it. Let's run it now. Yeah, so right now the server is up, and you can see it shows the port as well. So all we need to do is copy the address from here and open it into Safari. So let me just open up Safari real quick. So you can see it saw the GET request coming in as well. So right now I have already mentioned the team members and the team name as well. So next step is to upload a video. So I've already uploaded a small 10-second video which is under the static folder here, and you could download it from this link or like upload again from the static folder on that machine itself. And the reason is that since this is running on the CPU, so on my Mac I don't have a GPU. You could always deploy this to a GPU machine in the cloud as well. There will be some changes needed to run it on GPU, but the boost in terms of processing time is many-fold. So it is 20 to 30 times faster than running on CPU. So I'll just quickly show running sample. So this is the same 10-second video that I have uploaded in the link, and it's also present in the static folder as well. So this takes 2 minutes of time. So I won't be skipping forward or anything. I'll just let this run and process as it is needed. And in the meantime, I'll just walk through what actually happens. So you can see the spinner is showing up like, okay, it's awaiting something from the server. So on the left, you can see what's happened. So right now the file got uploaded. Then the first 30 seconds of it were kept. So in this case, it was 10 seconds. So it didn't really trim anything else. But if it was, let's say, more than a minute or so, it would again get trimmed down to 30 seconds. So this is only to make it so that the user, I mean, for the portal right now, is able to use it. I mean, instead of waiting for like 5-10 minutes just because this is a CPU, 30 seconds was like kind of agreed upon to like have some interactivity of some sorts, because 2 to 3 minutes is kind of acceptable like for this demo at least. So that is the first thing that we do. And then there is a 2 FPS conversion. So usually CCTV footages are not extremely high FPS like 30 or even 60 for that matter. They're usually around 5 to 10 FPS or in the range of that, and they are anyways customizable. So because people in a store are not in any extremely haphazard manner or like not in a hurry specifically, but every second if you get 2 frames, that is more than enough to know where they are and have sharp enough picture as well. So we ended up using 2 FPS as a speed, and that also enables us to have a faster performance. So if we had more FPS over there, this would correspondingly get slower in that much multiples of time as well. So that is the first stage that gets done, like converting the video. And then after that is done, we run the tracking on the video. So at that point, now we have figured out, okay, where the people are in each frame, and where have they been moving consecutively in every other frame as well. So that is another part which happens. And then we also have a frame split function. So that basically splits apart the entire video into different frames. Because here one of the key things was to extract the timestamp from the images as well. So while running the OCR on the images, what we found is, I think due to the overall complexity, scene complexity in the image, as well as the font or the color used for the timestamp as well. So most of the times the date would never be clear, only the time would be clear, and even in the time as well, the semicolons would be individual periods. So not semicolon, or it could be a mix of a period and a semicolon as well. So what we have done is applied some logic wherein for any given frame, what we do is we take up only the first 1/7 of the top and the bottom 1/7 from the image, and only these two are processed for timestamp. So if we would have paused the entire image, we would definitely take even more time than what it's currently taking right now. So having that smaller section of the image only being used for timestamps is kind of a heuristic, which we know that timestamps typically are at the top or bottom, not in the middle of a given CCTV stream. So that is the one of the quick performance optimization that we did. And one more aspect of it is, if at all we do get the timestamp in one of the images, we do not process the other one. So there's no need to process the top if at all we already have the time from the bottom. And in the CSV that we output eventually, so we again have implemented the logic for dividing this zone into 4 vertical areas and 2 horizontal sections as well. So yeah, so now this has been processed. So you can see it says timestamp OCR done completed. So now the output in this case, so we haven't just limited ourselves to a CSV. So what you can see here is a heat map of sorts. So on this, we have plotted out where the center of a box for a given person lies. So if you go back and look at the video that we had initially uploaded, you can check it out in the static folder or from the homepage of this website as well. Uh, it's a 10-second clip of the person just entering the store and staying here. So that's why the heat map is localized at this area. So instead of having to figure out from the CSV, okay, which sector or which zone it is, this gives you like a quicker understanding of, okay, here is where the person or like people are usually located at. And if you click on view results CSV, it takes you to the CSV page itself. So because in this specific video there was only one person and they stayed in A5, so it was 1, 2, 3, 4, 5, 6, 7, 8. So that is the time that they were in there and they got out. So it is in fact 10 seconds as the video itself was of 10 seconds duration. So that way we have kind of like hit our goals of this hackathon. A few challenges that we have faced is in the video, there have been cases where the people, let's say you have a person coming up from the back, and then if they turn around, so their attire from the front or their attire from the back isn't necessarily going to be the same all the time. So even their postures could also impact the same person be detected as a separate person altogether. So there is additional logic that we could have done, like squashing, if at all the center boxes of the same person, but with a different ID associated to him is presented. But that was a bit too advanced for us like to implement within a short time. So we kind of just skipped to having detections and also flattening out the same person over multiple timestamps of frames. So this is one of the frames, and like I mentioned previously, for the timestamp, how we are doing it is we have a lower and a top section of the specific frame. So you can see underscore lower is just the clip from the bottom, and underscore top is for the top. So by default, we start with the lower one. We get the timestamp. If we get the time, then we don't move on to the top. We just proceed to the next image to be processed. And I can also show you the raw output that we actually get from the model that we are using. So this is the output. So this output is then converted into the CSV that you saw on the website. So all of this pertains to, the first column is for the frames, the second is for the ID of the person, and then the next four are for coordinates. So this is top, left, left, top, width and height, and the last four are not needed. And you eventually come up with a CSV which is able to understand that and come up with this final tally of start time and end time. And this also works for different multiple users as well. So you can try it out with different videos as well. The only thing is it would take a while to process, and in order to even update or modify the same thing, it's pretty straightforward. The only duration that has to be changed is within the server itself. So you would just find a 30-second mark by simply searching for it as well. I can just show you 30. Yeah. So here, if you change this 30-second from the limit duration, that would enable you to have longer processing time as well as the timeout for each service. So we are keeping it at 60, and for processing we are keeping it at 600, which is roughly 10 minutes. But yeah, these could be changed depending on if you have CPUs or if you use GPUs as such for processing. So yeah, that's about it. Yeah, thank you.